These are the frequently asked questions for Algebra 2 for Section 4.2, Day 2, starting with number 31, and it's just because of the fractions in here that occasionally somebody gets a little stumped. So it says we're supposed to write it in vertex form. What we want to find is the coordinates of the vertex so that we can rewrite it. So we're going to start by using our little formula x equals negative b over 2a in order to figure out where that x coordinate is. And it's y equals ax squared plus bx plus c. That means our b value here is 3, so that will be negative 3 over 2 times, and our a value is 9/4. So little practice again with multiplying fractions here. You want to write 2 as 2 over 1, and then 9/4, and when you work with fractions, you really want everything to be fractions. So then you go ahead and reduce, cross-reduce there. 2 goes into 2 once, and it goes into 4 twice. Then top times top, bottom times bottom, and we get 9/2. So far we have negative 3 divided by 9/2, but of course we don't divide fractions, we multiply by the reciprocal. So negative 3 over 1 times 2 over 9, and again we can do some cross-reducing. 3 goes into itself once, and into 9 3 times. So top times top, negative 2, bottom times bottom, a 3. So negative 2/3 is the x coordinate of our vertex. And the next thing to do would be figure out what that y coordinate of the vertex is. And how we do that is by taking that negative 2/3 and putting it back into the original equation and seeing what we get. So y equals 9/4 times negative 2/3 squared plus 3 times negative 2/3 minus 1. Then we'd have 9/4, and negative 2/3 squared is going to be, let me write that up here, negative 2/3 times negative 2/3. So top times top, bottom times bottom, we will get 4/9. Then we would go ahead and multiply 3 times negative 2/3. Remember, it's like a 3 over 1, and then you could cross-reduce those 2 3's out of there. So that will actually be, when you multiply everything out there, a negative 2. Next thing, let's take care of multiplying those two together. You maybe already have done that because you can see there that when you cross-reduce, everything's gone. You get a 1. So y equals 1 minus 2, which is negative 1, minus 1 more is negative 2. So there is our vertex, and now we need a, we need h, and we need k to write this. And here is a right here. A was 9/4. So in y equals a times x minus h squared plus k, this will be y equals 9/4 times x plus 2/3, because minus a negative will make that a positive. Don't forget your little squared there. And then minus 2 in the back for k. So that was number 31. Next one on the list is number 38. And number 38 is just kind of odd because we did these maximizing the area problems 2 days ago, and they were a little bit different. This one says a town is planning a playground and wants to fence in a rectangular space using an existing wall. So here is how it's different. This time, we don't have to waste any fencing on that wall. That wall is already done. So it says, what is the greatest area that it can fence in using 100 feet of donated fencing? Well, the picture really says it all. I mean, if we're going to have the largest area, we're going to have to figure out the area of the rectangle, which is length times width. So that's going to be L times 100 minus 2L. We go ahead and distribute. We get 100L minus 2L squared. And knowing that we have a quadratic here, because that term is squared, we're going to go ahead and reverse these two. And then what we'll do is look at this as if it's y equals ax squared plus bx plus c. And pretty obviously, this one's going to be opening down because of our little negative 2 here. And the maximum point is going to be our vertex. So we need to come up with that, which means we're going to do x equals negative b over 2a and see what we get for the x coordinate of the vertex. Our b value is 100, so it will be a negative 100 over 2 times. Our a value here is a negative 2. So negative and a negative are going to make that positive. 100 divided by 4 is going to give us 25. So that tells us our L value here is 25. And then you could go back to the picture and figure out the length with that. You'd take your 25 and put it back up here. So 100 minus 25 times 2, or 100 minus 2 times 25, that's going to give you a width of 50. And what we wanted to know was, what's that greatest area that can be fenced in? So we'd have to take 25 times 50 to get that answer. And that will come out to be 1,250 square feet. You're going to notice in this example, it did not produce a square for us, and that's had an existing fence over there. This is not the same as the problems we were working on the other day. Another way that I wanted to explain that you can do this is, once you get that value for X, or L in this case, you can go ahead and place that back in the formula. You will also get 1,250 square feet when you do that. So it's just a matter of whatever one you're comfortable with. And then number 42. It's strange. It's not exactly the same as the one we did in class. The first thing you want to do is go ahead and put all of these in the correct order that you see up there. And then we have our negative 1, 3. And just like we did with the problem we did in class, what we're going to do is remember our little negative b over 2a formula. And x is the x-coordinate of the vertex, and that's right here. So we're going to put a negative 1 in there. And then a negative b in this case would be a negative of negative 2, so that's going to be positive 2 over 2 times, and then our a value up there. And what we're going to do is we're just going to ignore the negative in front of it and just fill in the space for a, because the negative is already there. We just need a. So we would multiply both sides by 2a and get negative 2a equals 2. We would divide both sides by negative 2 and get a equals a negative 1. So now we need to figure out what is c. And when we do that, we're going to use this a of negative 1, and we're going to plug that in so that our result, when we put a negative 1 in, gives us 3. And here's where the result goes, is right in that position of y. So now we would have the negative of, and then our a value, which is a negative 1. And then we have to put a negative 1 back into the formula, so negative 1 squared minus 2 times negative 1 plus c. And we have to figure out what all of that mess is going to be in the end here. So as we go through this, we have 3 equals, and we had this negative out in front and this nasty little negative 1 for a. And what we need to remember was that we already placed the negative once. So we don't need that extra negative here. Here's what I mean by that. Notice when we achieved our a value over here, what we really were looking for there is that a is just going to be 1, because the negative was already part of the formula. Now what I mean by that is, if we go back to the original, we could actually factor the negative out of all of those terms and treat it that way. And so that's what we're doing here by saying, all right, it was a negative 1, but the negative was already there. So all I really needed to put into the formula was a 1. And then we go on from there and just follow the order of operations. So negative 1 squared is 1, and that times negative 1 will give us negative 1. Negative 2 times negative 1 is plus 2, and then we still have our c hanging out back here. So 3 equals negative 1 plus 2 is 1 plus c. You subtract your 1 from both sides, and you get a value of 2 for c. Now, if thinking that way of leaving that negative off of there was messing with your head, you can always work with that one instead and get the answers that you need. Use the factored form of that. Take that negative out, take it out of the picture, and find A, B, and C. And so doing that the other way, you would go ahead and use that same point that we had of negative 1, 3. But really, treat it like y equals ax squared plus 2x minus c, and in the end, go back and distribute that -1, that negative that's out in front. So 2 different ways to go after that problem, just depending on which way you're more comfortable with. And then number 43. Number 43 says we're talking about the motion that we have a projectile, something being fired straight up at an initial velocity of 64 feet per second. So h is 64t minus 16t squared. And right away I notice that is not in standard form. So I'm going to go ahead and reverse that. And what they want is to find the time the projectile needs to reach its highest point and how high will it go. Well, I notice that I have a negative in front of my standard form quadratic. So this thing is actually opening down, and that's the path that I'm seeing as I do that as well. So if I can figure out what the vertex is, I can answer any questions that they have about this. So x equals negative b over 2a would be negative 64 over 2 times negative 16. That's going to be 64 divided by negative 64 divided by negative 32, which is just 2. So it's going to take 2 seconds for it to get to that highest point. And then if we want to figure out what that height is, what we do is we take this 2 and we plug it back in to that formula. So that'll be negative 16 times the 2 squared there would give us 4. So negative 16 times 4 will give you negative 64 plus 128, which will be, because 64 times 2 would give you 128. And that will come out to 64. And this one was given in feet. So that means that this distance right here is the 64 feet. Then number 47. Number 47 says we are supposed to find the y-intercept. And again, it's not that this one is hard. I just think with the fractions in there, some people get a little weirded out. And remember that the intercept is always going to be the y-intercept 0 something. So what we're finding is, what do you get if you put a 0 in there? So it'll be y equals negative 2/3 times negative 9 squared. Well, that's going to be negative 2/3 of 81. And again, if we're going to work with fractions and do a little bit by hand here, we're going to want to go ahead and do a little cross-reducing here. 3 goes into itself once and into 81/27 times. Then top times top, bottom times bottom is negative 54 over 1, which is just negative 54. So that intercept is going to be 0, negative 54. And those are the ones that I thought you might have a little bit of trouble with for section 4.2, day 2.